This is a particularly difficult homework exercise that you have to do. Traditionally, my students are always getting stuck on this one because the solving is actually really hard to do. And the solving is hard to do because you have a sine 2x and a sine x in it. And so when you set an equation with complicated expressions like this equals 0 and you try to solve, it's easy to get stuck. The short answer here is you need to be good at trig identities. And I recommend that you have a sheet of trig identities downloaded from your favorite website. I don't care where it comes from. Have that sitting next to you while you're doing your homework. It's really going to help you get through these problems more quickly. So I need to find all the x-coordinates of all the points on this curve where the tangent line is horizontal, and you should know tangent line horizontal means derivative equal to 0. So that means I'm going to take the derivative, I'm going to set it equal to 0, and I'm going to solve. The derivative is a chain rule type problem, right? So this is a composition with a 2x on the inside and a sine on the outside. So can you see how the sine became cosine here? And I still have 2x. And then right here is the derivative of 2x. And then this derivative right here, the derivative of minus 2 sine x, that's really easy. That's sitting right here. So this is the derivative. I use the chain rule. I'm going to set that equal to 0 and I'm going to solve. The first step is very easy. Divide by 2 on both sides. So here I am with cos 2x minus cos x equals 0. And this is what I was talking about. Many of my students get stuck right here. They don't know how to proceed. The thing is, you need this to be gone. You need this to go away and be replaced by something else. And so looking on my handy-dandy trig identity cheat sheet, I see that cos 2x is equal to any of several things, and I can pick my favorite. I have cos squared x minus sine squared x, 1 minus 2 sine squared x, 2 cos squared x minus 1. I can choose any of these that I like. Because I have a cos x here, I am going to choose this guy. He's going to be my winner. And so I'm going to substitute the cos 2x. I'm going to delete it and replace it with 2 cos squared x minus 1. See how the minus cos x above was copied exactly down here. So now I'm excited. I've done enough of these problems to see how I have a quadratic equation in disguise, and that this thing can actually be factored into 2 cos x plus 1 times cos x minus 1 equals 0. Now, if you didn't see that as quickly as I did, if you didn't see this as a quadratic, the trick is always to substitute. Just make up your own letter. I picked A, and you substitute an A every time you see a cos x. So here I have cos squared x, that's like cos x times cos x. So this equation turns into 2a squared minus a minus 1 equals 0. This may help you with the factoring part of this problem. In any case, once you're here, I'm going to trust you to keep going. I'm not going to finish this problem in video form. You split those, set them both equal to 0 and solve, and you're going to get your infinitely many solutions.